Right, and here I am. Sorry about that, everybody. I'm late. I'll be honest, I'm almost 20 minutes late due to some family drama that needed to be sorted out. But no, nonetheless, I'm alive, I'm here, I'm not as snotty as I was last week, so it's win-win all round. The intro is starting to grow on you, is it, Bixie? That's a surprise. Yeah, I'm still waiting for a nice big animation to be submitted. Oh, who else have we got here? So we've got Bixie, Jonisman, Siggy is here. Megetsup, good evening. Dr. Octo and Travis, hello. Travis, you're becoming a bigger name than you might think on our little Discord server. So do drop by at some point if you've not already. Pliskit, hello. Right, tonight I have entitled the stream Polymorphs, maybe. Now, do any of you watch Red Dwarf? Yes, I am using a new mic setup. Is it the right mic that's coming through? You can just see it just here. So this one is very close to my mouth, I think. Yeah, it should sound okay, I hope. Anyway, good. What was I talking about? Red Dwarf, that was it. Why was I talking about Red Dwarf? Because I've entitled it's a tad boomy. That's just me, Bixie. That's the authentic Javid sound experience. Just a boomy kind of guy. Alta, hello. I've not got any filters on, so it is just me. Yeah. Good. So, yes, Red Dwarf. Why Red Dwarf? Because Polymorphs. If any of you are familiar with the series Red Dwarf, I'm willing to bet there's a few of you are. They had a monster in it called a polymorph, and I have devised a type also called a polymorph. And I didn't realise that the two were the same thing until just before the stream. I thought, well, maybe we're starting to get a logo for all of this thing. That would be pretty cool. Yeah, it's quite an esoteric series. Yes, Alta, that's right. Why? What's happening? Why have we not got the editor in front of me? Well, we have. What I've decided to do is, after last week's stream, we started looking at how we're going to link together the polygons, the vertices, the layers, sort of having a think about the general overall hierarchy of it all. And I thought, you know what? It's actually proving a little bit noisy to code that in the editor itself. So let's just go and work on the basic hierarchy and the structure as a prototype in something else. Of course, naturally, I've picked the Pixel Game Engine just to get through this. That way I can sort of quickly code. We don't have to wait for compile times. I don't have to integrate it into WX Widgets or Pixel Game Engine 3. Let's get the ideas right and then move on. It also means the streams can be a bit faster and a bit more dynamic, and we can actually write some code. Who else have we got here? We've got Bogu, or Bo-G-U. Hello. Gruffler, hello. Good to see you, Gruffler. Oh, Rosso's here as well. Sorry, I missed out Rosso there. You don't want to miss Rosso out. Danicron, Speedy. Oh, good. Lots of people popping up. Yes, I did sort of announce that the stream would be starting at 8 o'clock. I apologise for it starting at 20 past 8. But that is resolved. So, what are we doing? Well, we want to look at how we're going to handle polygons. I mentioned something in the last stream where it would be useful if potentially we might animate some of these things at some point in the future. And that sort of sat with me for a little bit. I was thinking about it, I went for a run, was thinking about it, sat around, I thought, do you know what? If we're going to handle animation at any point in this entire project, if we don't do it from day zero, I'm going to regret it. It's just going to be such a nightmare to sort of fudge this in at a later point that we need to have something in place right now to handle this. And yeah, I think both is the answer. But today in particular, I'm going to be looking at shape keys. But the sort of relationship between layers could lend itself to being skeletal, depending on where you're from. So what I wanted to come up with then was some sort of structure which had a temporal element to it. So there's no easy way to go about doing this sort of step by step. So what I thought we'd do first, I actually went ahead and just hacked something up in the Pixel Game Engine to have a play with the idea. We'll have a look at some of this code and then how it operates, and then think about some of the improvements we can make to it. one of my fundamental drivers for thinking about things in vector is Pixel Game Engine 3. It's basically a 2D vector engine. But it occurred to me that most sort of formats for representing 2D vector drawing styles don't necessarily lend themselves towards to programming. Blender being a bit different, but I don't think people would typically like doing too much 2D work in Blender. Although you never know, maybe I'm wrong with that. But having the data sort of coordinated and structured in such a way which is conducive to being run on graphics cards and conducive to being understood and implemented by programmers of a variety of programming abilities. I think we want to come up with a structure which kind of harmonizes all of that together. So that's really what I'm aiming for with this particular editing tool. It's interesting that you have color baked into a vertex. If all the vertices have the same color, it does, yes, it would make the polygon a single solid color. Yeah, that's exactly right. So yeah, well, Alter's already started to read ahead, and you can see we're using the new Geometry 2D library. That's great. I don't actually think I'm using that yet. I've just included it by default now. And yes, this is a Pixel Game Engine application. What I'll do is get rid of all of this, yeah, and just have what we're working on today. So, as I just mentioned, the idea of why have I moved over to PGE just for the time being is so we can play with the data and we can play with the algorithms and piece things together. Porting that into the editor is a fairly humdrum and boring step, which perhaps shouldn't be the focus of the streams. I'd rather the streams have content in which is sort of a bit novel and useful. Gurad shading, correct, Magetsu, you're absolutely right, that's exactly what it was called. And actually a personal style I quite like. Technic Jelly. Is it gel or jelly? I know every time I read it on the Discord, I never think to ask. I think it's probably just gel. Let's stop coding horrible C++ and watch somebody else do it. Yeah, thank you. Oh, by the way, I filmed a video on Sunday. Isn't that exciting news? That was novel. I actually found some time. I've put a video together. I need to edit it, but hopefully at the weekend should have something new going up on the channel. So I'm pretty pleased with that. It's more yellow. No, it's jelly. Fluff is here as well. Hello, Fluff. No, it's definitely jelly from now on. In fact, you know what? We should try and find you on the Discord server and rename you as Jelly. I think Jelly makes sense. It just sounds right. Now you've kind of said it. Yeah, new video again. So sometimes I even forget that I do a bit of YouTube on the side. Right, yes, I've got a vertex. Now, I'm not going to get the OneNote out and scribble all of these things unless I really have to. I'm fairly certain most of the audience are familiar with the concept of a vertex on a polygon. It is one of the points. They are joined by lines and they define the outer boundary. And in computing, it's often common you have several other properties associated with a vertex. For example, we have the position, in our case, in two-dimensional space, and it will remain in two-dimensional space. We've got a colour. What colour should it be drawn at? You can have other things, and we will have other things. For example, texturing information. What if we wanted to texture these polygons? Not particularly a look I'm going for, but it might add some subtle ability to shade these things in a shader later on with a bit more information attached to it. And of course, you can have multiple levels of texturing, and you can have lots of other types of information these days associated with your vertices. Just ask Magetsu or Travis. The vertex is really sort of this very flexible sort of data structure, but right now, simplified. Remember, we're just cutting through all the crud here, getting to the point. What is this for? So my vertex represents a single point with a color, and I have a polygon structure, which remember talking alter ego was sort of starting to think about in terms of polygons for the Geometry 2D engine. So I've called it the same thing, and I think there might be some crossover in how we construct these things. Sorry, I just got a ping on the Discord, which is a bit unusual. I was wondering if it's Jelly complaining about being called Jelly. Lampan, a video? Yeah, I know. Hopefully we'll get a few more out this year. Stop people calling you Jelly. Oh, I bet you're well gel about the people You think you get it? No? Okay, I'll carry on. Struct polygon is a vector of these vertices, and we've got this rather obscure data structure stuck in the middle. This is something that's buried deep within the bowels of the Pixel game engine. It's actually there in most graphics APIs that use GPUs. It tells the GPU roughly how is the data structured, and by default it's a fan structure. Do we need to revise this? Is this something people in the chat are okay with? The different types of structures you have for geometry. So you've got, excuse me, we've got fans, you've got lines, we've got lists, and we've got strips in Pixel Game Engine. A fan is all of the points share one common vertex. A line is what it sounds like. It's a sequence of vertices all drawn with a line in between them. The list is a list. This is a bit of an odd one. It's a list of individual triangles. So you have a lot of vertex duplication in there. And a strip is sort of every edge is shared with the next triangle along. So sort of every alternate vertex is part of another triangle. You've never seen fan used before. I wonder why. Well, do you know, it turns out we had a discussion about fan recently. Magetsup and I did. Anyway, it's not there in some of the later graphics APIs. Some of them have dropped fan as a data structure. Rosso's being the one that's risking sounding like an idiot. It's not. We don't have that on this channel. You know that it's fine to ask these sort of questions. Maybe we could quickly just draw. I'll pull up the OneNote and we'll just quickly just draw some stuff. Pen, only because this is actually important, and it's actually, oh well, might not be drawing some stuff. Hang on. It's pretty important to how all of this is going to work. Excellent. So what is a fan? Well, a fan is vertex, 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 and if we specify the data in that particular order, we get triangles that look like this. See, they all share a common vertex. And it forms this fan shape. So it's great for defining circles and curves and things like that. What else did I say? We had line. So if we've got vertices, so just a list of them here, a line is simply what it sounds like. It's a single pixel wide line drawn between all of these vertices. If we've got, hang on, let me just move some of these containers out of the way. If we've got a strip, now strip's a bit more complicated, but strip is usually you have your vertices sort of looking like this. And a strip works by the first two get joined by a line, and then that forms a triangle, and then that forms a triangle, and then that forms a triangle. You see how it sort of flip-flops between each of them, and eventually you end up with, I've lost the sequence that I'm going in. Eventually you end up with this sort of long strip. That's actually quite a very useful one for constructing all sorts of things. And finally, the odd one of the bunch that I've got is list, which allows you to have just sort of disparate triangles fully specified. Of course, you can have vertices in the same place, but basically every three triangles defines a unique, every three vertices defines a new unique triangle. Yeah, that's right. So I think it was you were telling me DirectX 11 dropped it. Alice, hello. OpenGL still does have fans. Vulkan still, I see. I thought it did, but it was interesting why DirectX decided to drop it. If for no other reason, I mean, you can kind of do the same thing with strips, but quads. Oh, that's no good. What do I press? You know, Pixel Game Engine and nearly every 2D renderer on the planet will actually render a polygon quad when they're rendering a sprite. I've chosen the colours backwards here, but you know, choosing a fan makes sense. It's just very, very simple. I mean, you can do the same with lists. So, yeah, is there an argument to say that it's just a completely redundant type? Tricky. I don't know. Circles and things are pretty difficult to construct with these other geometries. If you did a circle using a list sort of layout, you'd have to construct it sort of like, I guess, there's my outer boundary. You'd need to construct your circle sort of like this. Right, which is maybe not as trivial as just a fan with a central point. I don't know. Yeah, maybe there is some interesting discussion points. Maybe there's some efficiencies which I don't immediately spring to mind. But that just seems like an odd way of defining that shape to me. So, yeah, there we go. A little bit of a refresher course on geometry. So, nearly all graphics APIs have these basic structures. And it's how this chunk of vertices, how are they structured in order to be drawn? It doesn't quite all disappear, but it gets even more complicated when you start looking at things like index buffers, and we're not going to look at that today. Right, we'll come back to that function in a minute. Now, I got carried away, as I usually do when I'm prototyping something. So rather than just doing what I needed, you start thinking, well, how do I do this but make it as generic as possible so I can use it in all sorts of different situations in the future? Let's see. Yeah, okay, cool. Thanks, Jelly. Yeah, we're going to be best buds, me and Jelly. Template classics. What have I got here? Right. So yes, I want to do something called. I want to include animation, and it occurred to me you can't do that sort of without thinking about the polygon types. Why not? Okay, actually, I'm going to pull up the OneNote again. We are going to need to have a look at these sort of things. Draw anime eyes. I don't know what's a. They're usually always sort of big, aren't they? And they have all of the pupil and everything coming. They always have a little like white bit in it there to show some reflection. They have a pointy nose, don't they? Yeah, I don't know. Right, that's as much as you get out of me. What was I talking about? We're going to look at white. Right, okay. So let's say you've got time flowing like a river in that direction there. Yeah, sorry, Magetsu. It's thoroughly disgusted. Is that link? No, it's just 3 stars. I don't know how to unmake it 3 stars. If you post it in the Discord somewhere, I can post it back in the chat, or somebody else can. So we've got time sort of flowing in that direction. What I want to do is have a sort of a set of points which can change over time. So let's say at this particular instance we have our 4 points like this over here, but maybe down at this end they've formed a different shape like that. I'll draw in some edges as well, since we're looking at polygons and things. Now, you've seen that the vertex is not just a position, it's also a colour as well. So I'm not going to shade all of these things in, just assume colours do the same thing. So over time, if we have at this particular time, I don't know what it may well be, but let's say at time A, the shape should look like this. And at time B, the shape should look like this. That's reasonably intuitive to do. We could pick any point in between those 2 times, and we can basically tween between the 2. So I guess it's kind of starting to begin to rotate and enlarge, right? It looks something like that if you were to pick an arbitrary point in the middle. And the nice thing is there's actually a whole bunch of different ways you can do this interpolation between these 2 time points, and you can get different effects. I remember once on the Discord, Let posted an excellent guide that showed you the formula, and there was about 30 different ones, the formula and the effect, a big animated GIF, and it was really quite informative of all these different types of animation. But let's just keep it simple. We're going to assume just direct linear interpolation. So time equals A is basically 0, and here we've got 1, and we can interpolate all of the points and the colours to give us some in-between time shape. And this in itself is also a polygon. So time equals something in between those 2 points. Just have a quick look. There's a lot of people going on in the chat. Post it on the CodeZone. Thanks, Jelly. Let's have a look. CodeZone. Isn't that the same article that Magetsu just linked? Yeah. Yeah, it's the same one. The worst part is Tech knows now that all of the regular Discorders watching today are going to call him Jelly for the foreseeable future. Oh! RHK gifted a tier 1 sub. Stop talking about hummus. I've just had my food, I'm okay. I quite like hummus though. Anyway, what I was saying is we've got a polygon defined here. Great, that's good. We've got a polygon defined here, and these are basically keyframes. And in between, whenever we want to sample this, we get a polygon. But there's something pretty critical about this polygon. And in fact, all of the polygons in the sequence, we can't easily introduce new points. So if we had sort of 5 points at this location and only 4 at this location, what does that mean? We can't easily change that shape into this one. We can bluff it by assuming it's a point that already exists. Maybe it's a point that exists at 0, 0. Maybe it's a point that copies something else. I don't want that headache to sort of make those decisions. So I'm making an assumption that anything in this particular keyframe timeline is always of the same size fundamentally. And there's some good reasons for doing that too. Javid doesn't even have sub-only emotes. I don't even know how to do that. I just don't use Twitch in the slightest. You have a star for the time being. I don't think I can do anything else with your name. What can I? If I click on your name, does it give me some options? I can whisper to you. Oh, well, I usually charge extra for that. I don't know how to. There used to be a way of like making people VIPs and things like that, but I can't seem to enable that. There we are. See, Jelly, people just want you to be here. Yeah. Change the steering category. You might miss a big raid. Oh, well. Oh, what a shame. Nobody ever sort of clocked yet that actually becoming a massive Twitch streamer is not the objective of the exercise here. So, yes, basically what I'm saying is we can't have different numbers of points. We can't lose points either. I know there are some animation engines where that is possible and desirable. I'm not going to have that kind of complexity. So what I want here is a polygon. Good. I want a polygon here. And as this polygon morphs into this polygon, we can get sort of any of the in-between states. And I'm calling this whole construct a polymorph. Because it's actually a genuinely temporal structure. We're going to supply this structure with keyframes, and we're going to have some arbitrary sampling mechanism to give us what that shape should look like, however it is sampled. And the whole thing is called a polymorph. So that's the theory. Let's go and have a look at the code. And oh, I forgot to talk about durations. Yeah, durations are actually important. Let's just pull that back up. So at the moment, and I'm undecided about this, and that's one of the reasons why I'm putting it in the Pixel game engine, is how long do these things exist in our time frame? So each stage, each keyframe is associated with a duration. Basically, the duration of this keyframe currently, and this is how it's currently done, might not stay this way. This here is one duration associated with this original image. So all of that is basically one keyframe. It's the duration and, it's getting a bit rude this drawing, it's the duration and the polygon. So then we get to this one, which again is this state of being displayed and some duration. And what we're going to do is when we sample, we can use these durations to work out where we should be in the image. Jared, in response to your question... Yeah, no, that seems like a legit reason. Well, see, this is exactly the kind of debate and discussion that we need to be having. So I would start thinking about getting it checked into a branch on the on the actual GitHub. If you haven't done already, I must confess I haven't checked. I'd get it having a look. I'd go and start a branch, and then people can pull it and start to play with it. The downside is you'll also need to update the testing application, or at least somebody will have to go and update the testing application. Luxord Knigny. Hey, I'm going to say Lord Kenny, or Lord... I guess Lord Connie in this case, because the X's. Yes, there we go. See, mate, what an educated guess that I made there. You see, Jelly, that's how easy it can be. You pick a name that's easy to work out, and then nobody gets it wrong. So yes, each keyframe is associated with this duration, and that's why I've got it right up here as a double format, this duration. How are you, Master? Ooh, well, we're not that kind of Twitch stream, but I'm all right, thank you. Yeah, I'm feeling pretty good. You want the same stuff? Hey, it's good today, huh? Good mood. I'm in a good mood. I'm feeling all right. I've got a video sort of in the bag. Kind of, maybe it's because if anybody watch West Wing, or you're all too young for West Wing. There's an episode where the president's about to just give a big speech, and to get him sort of psyched and ready to go, his wife, the first lady, cuts his tie literally as he's walking up to the podium, and they have to go and rapidly replace him. And as a result, his speech is like profound and sort of legendary. And I think maybe it's the rush of having to get to the performance on time, and that's exactly what's happened tonight. And that's why I'm running a bit late. Even though you Brits can't pronounce it, there's lots of things us Brits can't pronounce, but we can spell things properly. Right, so what I decided to do is, I think it's quite possible I'm going to be using sort of this keyframe animation things for other things too. And so I wanted to make this a little bit reusable. And it's sort of fluid and continuous. It's not keyframe as in sprites and things. It is designed to be something a bit more organic in feel. What are the other things? Well, we've talked about polygons. I'm also thinking of the idea of, and this is where we're definitely sort of branching off here. If you've got two polygons related to each other, so let's say we have a circle up here, and we've got a body, and the body has an arm. And we've got all of these sort of referenced to some local coordinate space for each of these sections, and this one might have a joint here. Therefore, we've got a hierarchy of shapes, so we could have like the body at the top, and linked to the body is the head and this arm. Well, the head and the arm will be linked via some sort of transformation. And it occurred to me that, excuse me, if you wanted to animate the arm or the linkages, and this is why I was thinking it's kind of both, okay? If we wanted to animate these, then we're going to have to change this transformation over time. So whereas the shape of the arm will change potentially, maybe it could get longer, or it becomes animated, or changes colour, that would be polymorph. The transformation can also change over time, and I was going to dub that, and I have no idea if this is a word or not, but a transmorph. So I'm basically suffixing the word morph to anything that changes in time. And that way we can sort of have these animations and these polygons all using the same underlying compute machinery to facilitate the drawing and swift animation. The difficult part is you've got to do some sort of search in time. There are ways to optimize that too, but that's a different stream. So yes, that's why I felt immediately I could think there's two things that need sort of this temporal interpolation. Yes, okay, good. So that's why it's become a template. And whatever this data is, I've no idea. At the moment it's going to be Polygon, but it could also be something else later on. And Pixel Game Engine 3 does have built-in transformation types. So having stacked transformations is not necessarily something uncommon and unavailable to us as part of the editing tools. Although Pixel Game Engine 2, we'd have to implement that by hand, and we'll probably end up doing it that way. So, to accompany the keyframe, I've got a keyframe sequence. Again, it's going to take in polygon as its fundamental type, and this is just a vector of these keyframes. Remember, each one has a duration and the polygon data. We're never going to have an empty frame sequence, so we've got to make sure that something is always there. That way, if you sample it, you're never just going to get sort of invalid results. It can just be empty, but it has to have something it can sample. I was hoping you might provide the polygon tests. Okay, I can throw something together which is based on a polygon. The thing is, I don't really know what the polygon structure is yet, so we may have to sort of flesh that bit out. Like I say, we can create a development branch just for polygon development and bounce it back and forth and see how it mutates. Right, so to couple with the keyframe sequence, we may have to find a particular keyframe at a given time. How have I handled this? Well, I've got two functions which look quite similar. Get keyframe at time, you provide a time. It's assuming at the moment, and this is all again up for change, that time is firstly linear, and secondly begins at 0. And so if you choose by default at 0, 0, you just get the very first polygon in the sequence with no particular change. In order to work out which frame you need to access, we need to have this function get keyframe index at time, which is a bit more sensible. And what this is doing and this is the nasty search, and there are ways to optimize this. We'll not do that today. We're just simply accumulating the time by iterating through all of the different keyframes and looking at the durations. And what I'm returning is the index of the frame at that time, and also how much time is left over. Simply, what does that mean? Well, if we go back up to this rude-looking drawing, I'll make it look less rude. Oh, I'll just leave it. If you were to sample here at a particular time, this is clearly the keyframe that we are returning, but I want to know what is the time to that sampling point from the beginning of that keyframe. So given the whole duration, that's not what I'm interested in returning. I just want to return what is the global time sampled from the beginning of that keyframe. And that's necessary because if I want to interpolate between this polygon and this polygon, I need to then normalize this time between 0 and 1, or whatever function we end up using for the interpolation. But I'm basically reducing it to 0 to 1 to make that process simple and customizable. Transmorph is in the dictionary. Excellent. I hope it's not been sort of taken over. I hope it could just be used as something simple. I don't have to go and think of something more complicated. So that's why we've got a pair being, I'm just going to grab a quick drink, a pair of things being returned here. The index of the frame and the residual time after that frame has been sampled. And it works reasonably well. This is not a great way to do it, but it's quick and simple to see if the concept works. I reasonably what's that? It's most entertaining. That's the subtle way, the subtle way of sort of saying, yeah, it's entertaining. Thank you. I appreciate any sort of feedback on it. Well, if you've only just found the channel, you'll find that this is nothing like the videos. It's chaos, unplanned, disorganized. And obviously unedited. But the videos are coming back this year. I've had to take a bit of a hiatus just whilst I'm sorting my little family out. And my little person is, would you believe, well, now 2.5 years old. And is capable of talking and answering back and all sorts of things. But effectively, when they go to bed now, they switch off for the night, which has given me some free time to start doing things again. Yeah, I think so too, Joe. I think it's a different way of coordinating. I mean, the thing is, there's the YouTube JavidX9, which is hello, and all that, and there's the sort of the real JavidX9, which is kind of what you see here. So it's 50-50 whether people ever carry on watching any of the stuff. JavidX9++ is doing very well, yes. And hello, by the way. Sorry, I missed that one. Right, I have told you about my very simple sampling. I have created a test architecture. So here we go. I've got a keyframe sequence, a polygon, and I'm calling it polymorph. We'll eventually reduce this to some custom type, but right now that is my polymorph. It's a keyframe sequence of polygons. And here in the onUserCreate function, which is called at the start of the program, I've added some stuff. I'll zoom out a little bit. So the first frame I've added, you'll notice I've got 4 vertices in each frame, because we can't change that number really. Once we've established what's there in the very first frame, all of the subsequent frames have to have the same amount of geometry in them, or else the interpolation becomes strange. So we can see we've got the polymorph, has its vector of keyframes. I'm adding. There's already one in it. That's why I can immediately just set the duration. I've set the duration, and I'm just now going to the data, and I'm choosing the vertices. And if you remember that this is, again, a vector of vertices, so a vector of keyframes containing a vector of vertices, and I'm pushing into that the vertices described as initializers, a bit lazy of me, but that's where they're existing in space, and that is the color. Then after 3 seconds, I'm saying I want another frame here at 2 seconds. The colors have changed slightly, and the positions have changed slightly. And again, 5 seconds. So in total, I've got 10 seconds worth of something going on in these 3 keyframes. Now, at the moment, I don't really know what to do at the end of something. That 5 seconds, presumably, will try and revert back to the start again, which might be undesirable. We might actually want to clamp that so you can define a start and end polygon. Hang on, what am I approving of? My name is JavidX9, and I approve this message. So I've added some keyframes to the polymorph, and my onUser update, which is called every frame. I know it's a lot of people will know this sort of stuff, but some people don't. I'm just looking at the follower count on Twitch. Sorry, I didn't realize it actually got that high. That's something I didn't realize. But we need one more. That's all. Well, so on user update, what I've done is I've actually not done anything with time, because it gets a bit fiddly. If things are just constantly moving all the time, I can't assess whether things are working. So what we'll do is we'll run the application. Let's have a look. Right, so what I have done in this application is, that's the very first polygon, by the way. I have mapped the horizontal position of my mouse cursor on the game screen to our temporal timeline of 10 seconds, whatever that means, 10 units of time. Because remember, this whole construction, this whole polymorph had a total duration of 10. So as I move my mouse across the screen, we're now iterating through the structures. Let's see if we can visualize what's going on. So there's the first one, and we said that that would take 3 units of time to get to the second one, which is defined as a perfect rectangle like that. Then we carry on moving to the third one, and then the third one, remember, it looped back round. Might not want it to do this, but right now that's what it does. Loops back round to the first again. See? So we can see that there's a relationship. And the nice thing is, this is all being drawn by the GPU, and we'll have a look at that in a moment. But it's a nice sort of smooth transition of colours and position in that data structure. It's the right way to spell colour. So the YouTube JavidX9 is fake? No, YouTube JavidX9 is usually not tired, because I might surprise some of you, but I do actually work all day for a living, and so coming home in the evenings and doing this after I've just cooked a meal, after I've just put little people to bed, I'm usually a bit knackered at this point. That's a British term. So yes, that's where we got to. So I think it's quite nice. It's nice and smooth. We're not taking any massive performance hits, but we've now got this ability to animate this polygon. Not in a transformational way, that's probably to come in the future, but we can change the fundamental geometry. For example, what if your polygon was like a palm tree swaying in the breeze or something? Just a nice little gentle animation. You see, my camera's not quite as zoomed in today, because I tidied the room, it's less embarrassing. Cream crackered, that's the word. That's right. So, yeah, very simply, we've been able to create this data structure. And that's it, right? So the only code left is this important function here. Once we've got where we are on the screen, so this is the normalizing of the horizontal position, I'm then calling my get keyframe index at time. And that's returning this pair. Don't forget, it's a pair of the current keyframe and the residual time left over. So it gets a little bit messy down here. From that, I'm getting the index of that particular keyframe and the next one. So I can work out which polygon I'm starting with my morph and which polygon I'm finishing with my morph. I then go and call this morph function, and we haven't looked at this yet. Let me just pull this down to a few more lines so we can look at them all on one screen. The morph function is the thing that's returning a polygon type based on a polygon going in at the beginning, a polygon going at the end, and some function t as part of our linear interpolation. And I've kept this sort of deliberately anonymous in a way because I kind of feel that with our templated structure of keyframes and keyframe sequences and sort of a companion morph function of how to morph particular data types could be something that you just sort of attach to it, or a lambda or something like that. Still sort of feeling my way through what's going on. But right now I just have this standalone function called morph. It takes in a polygon, and the interpolation between the two, and it's going to return a brand new polygon. The brand new polygon obviously has to have the same amount of geometry as the things that it's interpolating between, and it's also got to be of the same constructional type. The constructional type is important in the editor because I think you can draw different shapes and things, and it's kind of fundamental to how things are going to work later on. We'll save that for another stream. Then I simply go through all of the vertices of both polygons, and I can actually interpolate them. So the vertices are stored as vector floating point 2D numbers. They actually have their own built-in lerp function anyway for just linear interpolations. And the Pixel game engine actually can lerp between colours. If you didn't know, there is a function called pixel lerp, where you specify two colours in the same value. So that's actually all handled. Once we've constructed this intermediate polygon, we return it, and that's it. So it's a really nice way of then just sort of handling that data structure. So the critical part here was how did we convert that time into something useful and sampleable. Drawing it is not so trivial in Pixel Game Engine 2, at least. The first thing we'll need to do is make sure that the decal, because the GPU is doing this heavy lifting, the decal is of the type that we're going to use. So decals in Pixel Game Engine are basically a GPU hardware drawn entity. That's it's kind of the functional opposite of a sprite, which would be a CPU drawn entity. As a result, there's more limitations on how you can sort of a granularity limitation of what you can do with a decal, but there's at a higher level you can actually do a lot more with them because you can leverage the power of the GPU to handle the transformations and the sampling and the transparencies and any kind of blending modes, or can all be done on the GPU rather than the CPU. However, Pixel Game Engine can't work with the data we've got in our vertex directly. Pixel Game Engine 3 can. There's a bit of a difference here. So that's why we've got a little bit of code here to do a translation. A bit of a lazy one, where I'm just creating 3 vectors directly from the same size as the number of vertices we want to draw. I'm iterating through them and then populating those 3 vectors, because the draw polygon decal function takes in a vector of positions, a vector of texture coordinates if we were using them, and a vector of colours. I.e., we can't just pass in this vertex structure, we need to break it up into its constituent parts before it gets drawn. And by drawing nearly all of the draw decal functions in the Pixel Game Engine, if you specify null pointer, we'll actually just draw them as flat shaded polygons. Not a lot of people tend to know that, and it's actually quite a useful way for quickly drawing interesting shapes. So, yeah, quite a bit to get through there, and I'm pleased that we've one of the big design decisions I'm pretty pleased that I've made here is to actually just not for a moment focus on the editor, but to take it out of the editor to work on it sort of more concisely. And I think it's probably over the next week I'll be decorating this construction a little bit with some more usability interface. It'd be nice to be able to take a particular point in time. Let's go back to our OneNote. In fact, this is going to be essential. Let's say we were sampling and this is the point in time. We should be able to immediately turn this into a keyframe. We should be able to move keyframes around in this construction. This does actually throw up some interesting problems of its own right. Let's get rid of all this clutter. What are these interesting problems? The editor is fundamentally based on the fact that all of these vertices and things are actually going to be aligned with grid cells. That's a cosmetic and aesthetic choice that I like. They are, of course, editable, those grid cells, so you could set them to be very small and it becomes like a continuous editing domain. Of course, though, anything interpolated in between them may not necessarily alias with those grid cells. So you're going to end up with these sort of intermediate stages and forms of polygons which don't necessarily line up with the aesthetic of everything else, which is perfectly aligned with grids. I don't know how I'm going to handle that in practice. We may have to have something which is like a keyframe and then snap to grid. It also tells me that when I'm building the vertex editor where the user can actually drag these things around on the screen, I'm going to need the ability to select vertices that aren't necessarily aligned with grid boundaries. That's why it's worth doing these sort of things outside of the editor, so we start to discover these problems and think about how we can handle them, and whether, of course, we make these sort of things optional for the user. I think it's quite useful to be able to snap to the grid at all times, but of course that's going to look strange if this keyframe is in the middle of an animation snapping to the grid. Davey40k, hello. Yeah, we ran a bit late today, so we'll almost finish up. Another thing to do is, yes, what happens if we sample at the end of time? As we just saw right now, its sort of default thing is to wrap round back to the start. I don't think that's a sensible way to handle it. I think you should have a start and a stop. At least make this optional. So if you do want some cyclic animation, maybe a bouncing animation, for example, that's fine. Yeah, or what if we do want it to sort of ping pong back and forth between the two different shapes? So that we probably need to characterize those. Fortunately, I do actually have an animation PegX or utility file for the Pixel Game Engine anyway, which has sort of the core codes for doing this. We just need to look at how we handle the data separately. But certainly being able to clamp to the beginning and the end, I think, is quite important. Beach pants. Quake 2 base games have a snap to grid. It's so wobbly. Yeah, that's what I feel. Is everything is going to end up looking so crisp and unpixelated that to then suddenly have this sort of motion in space which becomes pixelated is a bit strange. Could AI be used to create millions of jobs and spread billions in wealth? In theory. Could AI create millions of jobs? As what? Prompt engineers? I think AI's got a limited lifespan. I'm going on record and say I think there's a bit of a flaw with the whole thing, and that is that as we generate more AI-generated nonsense, and let's be honest, that's mostly what we're doing with AI. As we go and generate all of these things, they've all got imperfections in, and the next generation of AI presumably will rather indiscriminately start training off all of this imperfect data, and so on and so forth, until it just basically becomes white noise and isn't of any use to anybody, unless somebody starts to then cultivate the input. Of course, nobody will want that because it's censorship. So yeah, where's it going? No idea. Will it create millions of jobs? Don't know. Exactly. It's a bit of a degenerating feedback loop. That's a better way of describing what I just said. More succinct. Then again, my academic background is in AI and machine learning, so I should be a proponent of it, but I don't actually feel I don't actually feel it's as cool as it. I mean, it's cool. Right? It is cool generating images and doing silly things with it. And I think some of the stuff I've seen is wonderful. And I think some of the medical implications of it are fantastic. But I don't know. I still can't sort of tell my phone to turn my computer on and send an email and do all that. So it just doesn't work. We're not there yet. Yeah, I think it's so impressive to the layperson that they're going to be blown away with it. To those with an understanding of the engineering behind it, and I do, albeit it's on a smaller scale and probably now 15 years out of date. But I, it's not as clever as it seems behind the scenes, and and that's what worries me, is that it can generate this incredibly convincing state that it's really right and it's really correct. And I know that's the anecdote of everybody. It can write text which seems very realistic, but everything about it, we just don't know how correct is it at all levels and at any point. And that's an interesting problem to solve before you can start fully relying on it to make decisions that are important decisions. Well, so I'm saying AI cancer detection, that sort of things, is excellent. We should be doing that. We should be ploughing money into doing that sort of thing. Looking for discrepancies and similarities in imagery is absolutely a perfect application of this. When I read graphic code like yours, I understand what is the intent. But I struggle to visualize what the code is going to do eventually. Do you think this? Yes, it will. It's absolutely an acquired skill. Being able to sort of look at code and go, what's this actually going to do? Particularly code, when you see it on the screen, this is not written in a way for other people to digest. But when you start looking at code that you've not seen before, trying to understand what it does just looking at the code is almost impossible. Fortunately, we have a big green button up here that says, like, do your thing. And immediately, by seeing what the application does, we can get a more intuitive feel for what the code does. This is one of the criticisms I've often had since starting the YouTube channel is why do you use things like Hungarian notation, and why do you have this sort of indentation style? And for me, it's to keep the code as readable as I possibly can without needing to know how it works. So I can arbitrarily take some sample of code in isolation and go, okay, I've got something here. IDX for me in my notation is standard unsigned sort of integer stuff. When it's D time accumulated, that's important. I'm thinking, oh, there's definitely some floating points things going on here. I know what kind of accuracy. As long as I can start to read this, like I can read a bit of sheet music, then things become easier to read. But that took years of practice. So yes, it can happen. It's not going to happen overnight. The green button tells us if we're good boys. That's right. The generative stuff is where the money is at the moment, of course, and why not? Right? That it's fun. It is silly. I'm sure we've all generated silly images. Live collecting is inevitable, and you start looking at where is it getting all the data source for all this, and it's not only just AI generated stuff putting noise back in, it's now getting all of its facts from sites which seem useful for AI. So you take something like Reddit, it's a fully curated and sorted list of the way people think about different topics. What a fantastic resource to just go and slurp into your AI algorithm. But then on the other hand, it's Reddit. Which very few people take seriously. And so I think when you look at actually social media as a whole being used as the data source, is it actually giving the AI any insight into the human condition? Probably not. It's the worst of the worst. It's absolutely polar opposite opinions all the time. It's black and white. It's never the grey area. It's never the nuance. It's never, and so I just don't think the data is reliable. It's an interesting topic. I think the technology behind it is fascinating, and it's as computer games were the driving force for at least the last 30 years of computer processor development, and it wasn't everybody think, oh, scientific simulation. No, gaming has been the most significant pusher of development in processing space, processing power, and more optimal processing systems and memory management, purely on the back of computer gaming. That is now kind of moving aside. For a few years, it went onto this nonsense crypto stuff, and then I think AI is actually going to be a real driving force for some significant changes in the computer architectures that we've become accustomed to. There's been talk about synthetic data being much better and more robust than the data we can feed it. Yeah, but I mean, synthetic data and things like that, they're just the output of the formulas. And there's an argument then, why, if you've got the formula for something, why do you need to train something to work out what the formula is? I'm trivializing a more complicated problem, but for the sake of filling in a few more minutes of this stream. Refinement through iteration. Well, exactly. We've not had a. We're trying to iterate through humans at the moment. It's not working very well, is it? Ubisoft is looking to steal voice actors' voices. You see, they're the kind of things, Alice. I know exactly what you mean, but that's sort of sensationalizing a slightly different problem. I think, great. What if AI can sort of do all these amazing things? What if it can make these changes? Brilliant. What if great. If it can just make somebody think differently about a problem. Great. Yeah, I tend not to get involved in sort of opinions on things, but it's just anybody that's sort of, and people do, they do a little bit of a background check on me and actually work out that this is something in an area that I've come from, but I've never ever done YouTube stuff about it, and I've no intention of. I've that part of my life is now over. Well, you see, that's the better way to phrase this, Alice, right? Right, and with that, thank you for there's a gift subscription there to Jelly, our new best mate Jelly. Everybody give Jelly a round of applause. Thank you to all of those who've joined the stream tonight. Some good numbers tonight. That's nice. I'm hoping that the format has been a bit quicker and more frantic, because we don't have to focus on this enormous big picture. We can focus on the bits that we're going to look at. It'll be a bit more focused as well for the next few streams whilst we flesh out this information. Yeah, good old Jelly. So until then, whoever just followed then, who was that? That was El Patatone. You are follower 6,000. There we go. Thank you very much. Right, with that, I'm going to blast out some rock music and see you all next week. I'll be on the Discord server for a bit. Yeah, we'll dance. Sorry about that. See you later.